Today in Britain there are some 13 million cars and about 1,200 miles of motorway. Tomorrow, in the 1980s, there could be over 15 million cars and 3,000 miles of motorway. The end of the car as the country's principal mode of transport has been predicted for many years. But with air travel very expensive and often frustrating, and the train services being what they are, the car and the motorway are by no means finished yet. The driver has become more demanding, and tomorrow's car will have to offer him tomorrow's combination of performance, economy, comfort, safety and style. Rovers have always appealed to the discerning owner. In fact, this is my second one of these. And actually, this model and its derivatives have been by far the most successful Rovers ever built. But now, after more than 10 years of refinement and improvement, the same designer, David Bache, and his team have produced a completely new and even better Rover 3500. But before we see it, let's look at some competitive cars. We'll pick out some of the features which have made them successful and which therefore had to be borne well in mind in designing the new Rover. First, the Volvo. Good sound engineering, extremely well put together. The Audi majors on fuel economy and all-round toughness. The BMW, a fine sporting image with performance to match. And the Mercedes, a car enjoying a high tradition in engineering and quality. The Peugeot 504, reliable, compact, but comfortable. The Renault, offering great versatility of passenger and luggage accommodation. The Citroën, advanced engineering, advanced styling. And finally, the Ghia, with a very complete specification as standard. Now, quite clearly, to be competitive, a new car in this range would have to incorporate all those features and more. And Rover believe that their new 3500 has done just that. The advanced styling may not immediately suggest Rover, well, not in the traditional sense anyway. But once inside, there's no mistaking the breed. First impressions are spaciousness and very good all-round visibility. The driving position is comfortable, thanks not least to the easily adjustable steering column for rake and height. The instrumentation is good and easy to read. There's a battery of warning lights, and the control system is well marked and self-explanatory. In addition to the conventional warnings, there are lights to indicate seat belts, handbrake failure, bulb failure, the rear fog guard lamps, and the heated rear screen. You can judge for yourselves the quietness of the interior. We're bowling along at exactly 50 miles an hour in a very well ventilated, comfortable environment. The luggage space is important and will appeal. It can expand from 12 cubic feet to no less than 35.5 cubic feet with the rear seats folded flat, and the whole space is carpeted. Motorway, 70 miles an hour. The standard equipment includes a 3-speed heater fan, twin rear-guard fog lamps, and there are twin speakers to the push-button radio and tinted laminated glass. Now, fuel consumption, very important, of course. Touring tests indicate about 25 miles to the gallon, and at a constant 50, about 30 miles to the gallon, which is pretty economical for an automatic 3.5-litre V8. To sum up, a car of style, good road holding and a comfortable ride, power-assisted steering and braking, 0 to 60 in less than 9 seconds. In fact, everything you'd expect from a car designed for tomorrow's driver.
People have always come in all shapes and sizes. Apart from age and sex, it's surprising how many differences there are. Cars have also varied a good deal. They haven't always fitted people very well. Whilst some designs were obviously for impressing the natives. Of course, one way of making cars fit people was to make them bigger and more spacious. This didn't always work out. Making them bigger didn't really make them better. Not that all big cars were bad cars. Sometimes they were luxurious and impressive, but hardly economical.
The starting point in designing a new car may seem to be appearance, but there are many factors to be taken into account. And although full-scale clay models help to give Leyland Cars executives an impression of the finished car, the real decisions are made during prototype testing. In wind tunnel tests that give the clues to low fuel consumption, high touring speeds and road holding. In crash tests to protect the passengers. In sub-zero tests in actual conditions. And in tests on alpine roads where engineers from Leyland Cars perfect brakes, acceleration and road holding. All this practical testing results in the end in something like this: sleek, economical, comfortable and safe. In fact, it is a long way from that other age and designing on the factory floor. Today, we need a car that is scientifically designed and tested, that not only looks good, but feels good, and that is, above all, supremely practical. Such a car is the new Rover. It is a car which has been designed with people in mind. It would be difficult to give it a Christmas present, for it is the car that has everything. 4 doors and large, fully adjustable seats which are extremely comfortable and beautifully upholstered. Seats that are contoured to give perfect back and leg support. A steering wheel that is adjustable both for rake and length and has a safety collapse column. Fingertip controls and vents along the doors to demist the side windows, with hot air fed from the main ventilating system, which is fully controllable and distributes fresh air all over the interior. The push-button radio is standard, and the outside mirror is adjustable from the inside. All 5 doors can be locked from the driver's seat, or by key, both front doors can be locked from the outside. Thought has gone into every extra that can possibly contribute to the comfort and convenience of the passengers, and everything has the stamp of Rover quality. But people using the new car are the ones who should be talking about it.
Tons of room in the boot, and a boot light. Mind your head.
Yes, jolly good.
Locking petrol cap.
That's important these days.
Yes. Interesting thing about the doors. Got a warning light, by the way, but they open to 2 positions. See? Very useful in a car park.
Oh, it's got lights under the bonnet.
Yes. And this gadget, the man in the service bay plugs in and you get a complete engine analysis.
Looks powerful. Is it quiet?
Oh, yes. Can't hear it at all when it's running.
A sporting-looking car has always been a bird catcher.
Taken by surprise by a pair of roguish eyes. In a moment my poor heart was stole away.
And of course, we're more discreet today.
The Rover 3500 is a car for all ages. It is also a car for Europe.
Is it the new Rover? Yes, it is. Très élégant. Vous le regardez? Jolie voiture. Would you like to look inside? Oh, volontiers. Très bien. Est-ce facile à entretenir? Très facile. Très confortable. Un petit coup de brosse et rien du tout. Très bien. Oh oui, c'est formidable. La couleur est jolie. Oui, c'est très agréable. Voulez-vous vous asseoir? Je peux? Sit down a little. Have a look. And then, of course, there's that. Your handbag. Très bien. C'est bien. And that is the sunroof. Le toit ouvrant. Le toit ouvrant, vous pouvez. Vous allez voir, c'est facile. Oh, très bien. Très agréable. But of course, in England, it's the heating that's important. Oui, je comprends. Est-elle facile à conduire? Ça marche, c'est merveilleux. Très facile. C'est, comment dire, assisté. La direction assistée. La direction assistée. Assistée, oui. Et les freins. Les freins assistés aussi. Freins aussi. Très bien. Oui, et bien sûr le automatic gearbox. Vitesse automatique. Vous la conduisez souvent? Quelquefois. Quelquefois. When my husband will let me. Oh, quand votre mari vous la laisse.
As a car for Europe, the new Rover is designed to be comfortable, elegant, economical, and fast. It looks right in Switzerland, Germany, Holland, any country that demands sophisticated motoring. In short, it is an elegant example of functional design, and like all Rovers, it is quite unique.
Papà, facciamo 200 chilometri all'ora.
Ma imbecille, guarda dove vai! Guidi troppo in fretta, sai, vogliamo arrivare in un pezzo. Ma perché non mai guardi dove vai? Abbiamo il bambino con noi. Ma sei proprio un imbecille. Guarda la strada, sì? Oh.
If that little bambino had kept his mouth shut, his mum would never have realized that they were traveling at over 120 miles per hour.
You might not want to do 120 miles per hour, but one of the reasons why the new Rover is so fast is because of its shape. In other words, because of its low drag factor, which is one of the reasons why it's so economical. Rover has long been a traditional name for quality and advanced precision engineering, now translated into a super-modern concept, a car that fits into any occasion. For Rover have developed the habit of thinking of things that are different and better and are very, very useful, especially for families. It is indeed a real family car, whether at hunter trials in England or in a Bavarian village in Germany.
So, you bought a new car after all?
Sieh dir doch mal an. Weißt du, mir gefällt vor allen Dingen der große Kofferraum. Das kannst du rausnehmen. Dann kann man natürlich Platz machen mit dem. Ist doch fabelhaft.
Und was hast du sonst noch auf Lager?
So. Das lässt sich herausnehmen. Und hier. Das ist dein Raum.
Poor chap. He's working hard.
Da, sehr schöne Polster. Radio. Für dich extra ein Schminkspiegel, damit du nicht immer in meinen guckst. Dann hier. Elektrische Fensteröffnung. Und schließen. Hier hast du genügend Platz für die Handtasche. Großes Handschuhfach. Und die Hauptsache, die Liegesitze.
Aber dafür, das sind wir doch...
Well, maybe she's right. He may be a little old for that, but there's no doubt that this is a car full of ideas.
Also was mir gefällt, das ist der 3,5 Liter Motor und die 5-Gang-Schaltung.
Ja, ich hätte natürlich auch eine Automatik nehmen können.
Nein, nein, eine 5-Gang-Schaltung ist wesentlich.
She really doesn't have to do all that hard sell on the engine. But it's nice to think that the car has features for both of them.
Und wenn wir bei dieser Straßenlage in die Kurve gehen.
Also, es ist ein Wagen, der zu uns beiden passt.
The new Rover is a car which has been designed as a new approach to European motoring. It was planned not only to fit human beings, but to fit our new society. It is comfortable and has perfect manners, and yet it is not an old lady. It is fast and has superb road holding, and yet it is not a sports car. It has smart, sleek lines, and yet it is made to transport a family and their luggage in comfort. It is astonishingly economical. It is what everyone wants today. An all-rounder. A car that does every job and is right in every situation. It is a car that is made to fit people.
Good looks, appeal, style. Today's car must have all these features and more besides. It's also a highly sophisticated piece of precision engineering. Today's tough driving environment demands high standards of design, development and testing. Leyland engineers use advanced technology to design cars to exacting standards of comfort, durability and performance. They use computers right through from basic calculations to complex programs. Without the need to build even a single component, it's possible to predict the behavior of a new vehicle and its occupants under all road conditions. A new car begins to take shape when the engineers and marketing men agree on a package. Their specification includes performance, passenger space and luggage capacity. They hand over to styling. Stylists produce many sketches, and some are chosen as a basis for full-size clay models built by skilled craftsmen. At this stage, the design, style and engineering team must meet all practical problems of manufacturing, engineering and legislation. The computer helps to obtain an exact mathematical representation of the clay model's surface. This machine measures a complete full-size styling model to within 1/100th of a millimeter. It does in hours what used to take weeks before computers. The car body engineer uses mathematical techniques to analyze the surface shape. He must decide how best to split the shape into the individual panels which will eventually be assembled into the finished vehicle. These separate panels are stored on magnetic discs. This information is used repeatedly for the design tasks which follow. Whenever drawings are required, they can be produced automatically to any scale or view. Connected directly to the computer, this automatic drafting machine makes drawings at speeds in excess of 15 meters a minute. From the earlier stages of design, structural schemes for the internal panels and understructure are developed. To assist in this development, a complex structural framework is designed and fed into the computer. The computer can now accurately test the structure without the need to destroy expensive prototype vehicles. While structural engineers develop a body shell of the right strength and weight, other engineers must find ways to make the car ride comfortably, must find plenty of clearance for the wheels to move up and down as the suspension absorbs road shocks and cornering loads. There must be room for the front wheels on full lock for all movements of the suspension. The engineer's practical knowledge and experience are combined with accurate fast calculations by the computer to cut the time all this takes. It also enables designs to be evaluated in the laboratory at an early stage. The geometric layout of components for a proposed steering and suspension system is fed into the computer. In seconds, the position of the wheel for any steering and suspension condition is calculated and drawn. The steering and suspension components must provide the driver with precise response. The drafting machine can draw the turning circle for any proposed steering system. Oversteer and understeer are conditions which can be evaluated by the computer. Designing for safety, our engineers are just about the only people who intentionally crash cars. Leyland engineers go to extremes to protect the occupants should the worst happen. Mathematical representations of the mass and structural stiffness of a car can be analysed by computers to predict what will happen in an accident. There is less need for costly destruction testing. There's no need to build prototypes to test the effect of changing the engine's position, seatbelt anchorage points or body component stiffness. The computer will simulate them all and determine the best way of absorbing energy to protect the car's passengers. Too rigid a structure may cause the passenger internal injuries. Too flexible a structure will allow the engine or other components to penetrate the vehicle interior and injure the passengers. Safe design prevents accidents. The driver needs maximum visibility, but there are obstructions to vision. The engineer must minimize the blind spots. Once again, the engineer calls on his computer. He must reduce the blind spots without weakening the car. From the Arctic Circle to the tropics, every driver needs to be able to see clearly whatever the weather. Computers help design windscreen wiping and defrosting systems. In windscreens, difficult heat flow calculations are speeded by computer. Different pivot points and wiper blade shapes are fed into the machine. Engineers can quickly calculate whether the most important areas are adequately wiped. This car has been made from several hundred pressed steel panels. More than 1,000 press tool operations are required to make these panels.